Hey, welcome back to Math with Patrick. Today is August 8th, and we're solving problem number 220 from the Daily Epsilon calendar. And today's answer should match today's date, so we should get an 8 for the answer. So let's see if that happens. A set of test scores are normally distributed with mean 100 and standard deviation 15. I would actually use the word is here because it says that a set is normally distributed, but oh well. A set of test scores is normally distributed with a mean of 100, and so usually you could draw like a sketch with like a normal distribution curve here. So it kind of starts low, it peaks in the middle, and then it kind of symmetrically goes back down. And our mean is 100, and standard deviation is 15. That just means that it gives us some information about the spread of the data. And usually when I sketch these things, it takes roughly 3 standard deviations to get to this kind of like really, really small part. So this is just kind of an eyeball approximation, but each of these jumps should be 15. So we can go like 115, 130, and then 145. And we can count down to 85, 70, and then 55. So this actually looks roughly like the distribution of IQ scores. So maybe that's the kind of test that we're talking about. IQ scores are averaged to have a 100 as the mean, and then I'm not exactly sure how they choose their standard deviation on those tests, but 100 is the exact average for an IQ score, so that's what I'm imagining here. So we're trying to find what percentile is a score of 79. So if I maybe count by my fives, this would be 75, that would be 80, and so 79 is roughly right here. And when it's asking for percentile, this is going to be some kind of percentage where that is how many, or like what proportion of, say, the people you are above on this IQ test. So we're basically trying to figure out what the chunk is here in comparison to all the people who took the test. This problem would be like super easy if it asked you like what's the percentile of a score of 100, because then we would know that there's 50% of people who are at or below your score, and so the answer would just be 50 if this were a 100 here. But since it's not, it's a little bit harder. I do know that the answer is going to be well below 50% and probably under even like 25%. I mean, we both know the answer is supposed to be 8 today. Essentially, we just need to know what chunk, what fraction this small bit is of our whole 100% of test scores. The best way to do it is to calculate the z-score of our percentile, or rather of our score. A z-score kind of tells you how many standard deviations away from the mean you are. So like, for example, a score of 175 would have a z-score of 3, simply because it is 3 standard deviations away from the mean. So our z-score on the left is going to be kind of negative because we're counting backwards down the scores, and it's going to be somewhere between -1 and -2. So I'll say that it is less than -1 and greater than -2. Because this score right here would have a z-score of -1, and then the 70 would have a z-score of -2. To calculate where this is, or what the z-score should be specifically, we could just do 79 minus 100 and then divide it by 15. Again, just kind of justifying why I'm doing this, if we did put the 85 here, we would get -15 over 15, and that's going to be equal to -1. And so if it makes sense to you that a z-score of -1 kind of means moving backwards 1 standard deviation, then you can kind of see how, okay, cool, I got the number -1. This formula makes sense for the 85. And so it should return me some useful information about when I plug in a positive 79. We will get a negative number in our numerator. That's going to be -21. And I guess we could simplify this down. We could divide the top by 3 and the bottom by 3. So we get -7/5. And I am going to convert it to a decimal here, just because when you use z-scores, usually you see them as decimals instead of fractions. So this is the same thing as negative 1.4. So that's not our answer today, but it's really useful to figure out our answer. Um, to be able to go between z-scores and percentiles, there's usually two best ways to do it. You could either consult a z-table, which I'm going to show in like 10 seconds, or you could use a calculator that has like a normal distribution or an inverse normal distribution function, depending on which way you're going between z-scores and percentiles. First, at least, let's consult that z-table, and we're going to keep in mind that our z-score for our test score is negative 1.4. Here's one version of a z-table you might see in like a statistics textbook, or you could even just Google z-table or z-score to percentile. I just Googled it and found this image and felt like using it. I do like how this one starts out with like a picture image of what we were doing. And this picture matches what I sketched out earlier, where we have some kind of normal distribution curve. We know the mean is somewhere in the middle. And then we're trying to figure out what's like essentially the probability that we're at or below our target score. And since the mean was 100 for our problem today, it would make sense that we're looking for a value on the left side of this mean value. And this is what the table looks like. It's kind of hard to read at first. Essentially, you are looking for your z-score along the horizontal and vertical axes, and then you're going to get information about your percentile somewhere in the middle here. First, you'll look along the left side and try to find a number that's roughly around the z-score you want. For today, we had a z-score of negative 1.4. And then if you wanted to get more specific, like say your z-score is like negative 1.45, then here you can have different hundredths digits. And so I would go to this spot right here to get my 0.05, that 5 hundredths. And so if I really wanted to figure out the percentile for a z-score of negative 1.45, I would look down here on my table. So then we get negative 1.46, 47, 48, 49, and then we could jump to here to get a z-score of negative 1.50. Anyways, that's how I'm reading it. All I really need to look at is this number right here, and it tells me that the percentile in decimal format right now, corresponding with a z-score of negative 1.40, is 0.0808. So let's bring this information back to the whiteboard real quick. So using the z-table, we know that the corresponding percentile is going to be 0.0808. But this was just a decimal version. And if we wanted to convert it to a percentage, which you usually see percentiles as, all you need to do is hop the decimal point twice over. So the answer today, according to the z-table, is 8.08%. I'm assuming the calendar here doesn't really mind that we're rounding a little bit. Honestly, if you were told that you're in the 8th percentile or the 8.08th percentile, it doesn't really matter either way. You scored kind of low. So that's how we can use a z-table. And how about to cap off this video, let's hop on over to Desmos just to see what it might look like using a calculator. On Desmos, you can just type in normal dist, and then once it turns like unitalicized, then this is like a function that Desmos understands. Opening up these parentheses, you are able to plug in a mean that you want and a standard deviation that you want. The default is that your mean is 0 and your standard deviation is 1. You can even hit this zoom fit to kind of get a nice zoom in on the curve. But our mean was 100 and our standard deviation was 15. Currently, we can't see anything, so let me click this zoom fit button, and there we go. So this shows me that there is a pretty high probability, well, not that high. It's roughly 2.6, 2.7% that you'll actually score 100. Well, then again, maybe not. This is just a representation of this distribution, because like on an IQ test, I'm not sure if you can score a decimal number point. Like I don't know if you'll be able to score like a 102.4 on an IQ test. So I'm not sure whether we would need like a more discrete probability distribution where we have specific points. But regardless, I don't think it really matters. We have our normal distribution with the correct mean and the correct standard deviation. Just to show where 79 is, I could do y equals 79. Oops, positive 79. I think I actually wanted x equals positive 79. There we go. That gives us a nice vertical line on which our score will lie. And we just wanted to find kind of this cumulative area or probability that we're going to be at this score of 79 or below. So if we click on this cumulative probability kind of tab or down arrow, we can see that currently it's set from 85 to 115. And so it's highlighting this area for us. And it looks like this is equal to roughly 86.3%. So we could adjust these bounds to figure out what our cumulative probability is of being at or below 79. And this does go to negative infinity, which I guess is what we wanted. You could even put like a 0 right here, and it didn't really change our answer. That's just because the probability of scoring like a 0 on a test like this probably is like almost impossible, right? Like scoring even a 40 looks pretty impossible, though, maybe is possible if you happen to not answer many of the questions right. Anyways, just to be the most accurate, I think if I delete this 0, it'll autofill in that negative infinity again. And then we can see that the cumulative probability that we get from Desmos is actually more accurate than that Z table. We're going to get kind of more information here, and it shows that that Z table was rounding to the 4th decimal place here. I could also fudge the numbers if I really wanted this to be exactly 0.08. Maybe I'd have to like decrease this number a little bit. But at this point, I'm just kind of playing around with the numbers and seeing what happens. And it's a little bit of a guess and check on my part to figure out once I get even closer to this exactly 8%. But I think that doesn't really matter too much because in the end, we just needed to round for today's answer. And it's this 8 right here that represents roughly an 8% probability of scoring at the 79 or below. So there are 2 ways to solve this problem, either with a z-table or with a graphing or just statistics calculator. And I think we're all done. Hope you enjoyed the video, and I'll see you tomorrow. Bye.